This is a graph of an elementary reaction. You have reactants here and products. This is exothermic here. As these reactants, whatever they are, let's say it's two things, come together, up here, when their activation energy is achieved, they are in a transition state. That is not an intermediate. When they're in a transition state, they might be rotated or moved so that they can break a bond or form a bond. A transition state is not an intermediate because it is not a permanent thing. In this particular, if this was an elementary reaction and this was your reactant and this was your product, and it was just, that was it, that was the only reaction step, then there would be no intermediates. However, let's say you have two steps. Let's say you have a reaction like this, and then whatever is formed here, I'm going to call it AB. So you started with A plus B. This isn't really going to, I haven't given this a lot of thought. It's not going to work out perfectly. But this AB then could be involved in a second step, which might look like this. Okay? And AB might react with C to make A plus BC. Now I've made him, so therefore AB is an intermediate. It is a real molecule that is formed at the end of the first step and then used as a reactant at the beginning of the second step. In order to have an intermediate, you have to have two steps, and I think that is the answer to your question. If you are only shown one step, there can be no intermediates because you have beginning things and ending things, and what's up here is the transition state. This is the transition state for AB plus C. In order to have an intermediate, you must have two steps. If you're only given one reaction, one step, you won't have any intermediates because whatever you produce is what you produce. Now they may be only showing you part of the mechanism, but for the purposes of the question they ask, if they just give you this, there can be no intermediates unless they give you other information. What is at the top here is a transition state.